So finally, a topic, DNS over HTTP, this time encrypted version HTTPS. I will come back to security encryption in a separate chapter, but here the idea is we bring together two concepts, DNS, we discussed this, and HTTP. Why DNS and HTTP? So wasn't DNS the idea there that you also send a request for, let's say, Amex records, and then the answer is first a name plus the address of a mail server, for example. Okay, so we have a request response scheme client server. Request response, in this case, using UDP, for example. There's also DNS over TCP, but I said, okay, in this case, reliability we can handle by repeating our requests. But request response, this rings a bell. That's exactly what we do in HTTP. There's also request response. So why not using HTTP for DNS requests? Because this also transports requests and gives us responses. So what is the idea here? So why not sending the DNS queries over HTTPS and also get the DNS responses over HTTPS? So that's the basic idea, and the advantage and the disadvantage is it's hard to distinguish from normal HTTPS traffic. So in the end, if you let the traffic through, if you optimize systems, etc., if you already have a server, so then why only getting requests, HTTP requests for web content? Why not also for DNS content? So this helps in some settings for firewalls and for other things, but it's also a problem because you cannot look into the traffic anymore. It's DNS, but it's hidden somewhere in the HTTP traffic. So we come back to this. So the DNS query response pair is now mapped into an HTTP exchange. So it's also sometimes called DoH, so DNS over HTTP. So this fits perfectly into the idea of HTTP. So we can use caches. Hey, great. Yeah. So with the classical DNS, there is no caching. There are different DNS servers that can cache answers, yes, but this was caching only for DNS. Remember, we asked a DNS server, and if the DNS server already has the answer in its cache, it can answer. But that's a specialized cache. Here, with the more general principle of HTTP cache, and now we cache, besides JPEGs and text and style sheets, we also cache DNS. Sounds good. We can use HTTP proxies, we can use all the compression there. We learned HTTP, there's compression. That's cool. Normal DNS, no compression. Here we can use this. So, and we can also actually use the existing browser APIs for programming. So web applications, if you want to access DNS, use the normal API. So that is the idea. Okay, so how does it work? Well, it's relatively simple. So you configure the client. So in your browser, you also have the DNS over HTTP client. You configure it. Basically, you have to do this like the DNS server. You have to tell your client, now this is the DNS server that can handle DNS over HTTP. So this is not the normal regular DNS server anymore. So it's like a link. You actually tell the client now the new DNS server is dnsserver.example.net, etc. So out of band, you can do this. And then you know it, and the client now can choose this DNS over HTTP server. So you can have different, etc. So quite flexible, but what we do is we use the mechanisms of HTTP URIs to configure now the client for DNS. Okay, and what do we do then? Well, the DNS query is now an HTTP request. You remember DNS queries, you ask for something in this ASCII text, etc. But, we use HTTP2, we can compress this, we pack this here, and then we actually transfer it using HTTP request, and so that you know what's going on. Hey, this is this MIME type, media type application DNS message. So you know text, HTML was an example here. We have application DNS. So we have a certain method, get, you see this HTTP2, and then we use HTTPS, goes to a certain DNS server, that was the one configured before, and then we transmit our query, but in this case it's, well, you see, it looks like a path with a certain argument. Okay, so this is not our 7-bit ASCII anymore, but that's our DNS request now, coded into a path query with the method get, HTTP2 as a minimum. Okay, so that's our request. But that also means you cannot debug any longer. It's not clear text any longer, so you need other tools. And then the response is also an HTTP response. Yeah, so like for web pages, there's a status 200, that means resource found, everything fine. But in this case, it's not a JPEG or you remember text HTML or something like this. In this case, as we've seen, application DNS message. So with a certain length, so these are our 61 bytes here. And then we have a hex encoding, that's the answer. Okay, additionally, we know in the web we have caches, web caches, and there's a certain age assigned to this response. Okay, age here for HTTP request, but we know that DNS also has a certain age. You remember all these records, they have a TTL assigned. So, is this the same? Well, it depends. So now we use a cache made for HTTP. So the cache implementation might be aware of DNS over HTTP, but doesn't need to. So the problem is, okay, now we have different cache settings. One is the cache setting that is just delivered via this HTTP response. And one is what we originally had in the classical normal DNS server. So there are some shoulds and what you should do. So also in the standard, so the lifetime, this should fit, and it's written that the lifetime should be less than or equal the TTL in the classical DNS answer, so that this matches. Because otherwise it could happen that your cache holds outdated DNS information. You say, oh yeah, that's the answer, and you cache this for several days, then you can change the real original DNS entry and nothing happens because you always access this outdated cached entry. So that's the idea. So that's one thing. You can also customize responses based on client IDs. So DNS can now be personalized. And then you can tell the cache, oh, no, don't cache this. This is now a personalized response. Now remember, that's a good idea for some companies that can give individual answers. Now, individual answers, for example, depending on your browser type or whatever, on your behavior, on whatever you think, because now it's not the operating system, the classical DNS that basically does a DNS lookup. No, it's the browser that does DNS over HTTP, and we can now see together with the HTTP, with this request, we can do a lot more. So that's the idea. Okay, so here I will not go into the details of how this is implemented, but look at this more from a system perspective, because we always think in systems and what happens if you bring a solution from one world into another world. So DNS resolution is now implemented in the application, not the system. So system, that would be the classical one. So remember, we perform DNS lookup. Okay, and then that's in the system, we get an answer. We can also do all the HTTP stuff in the operating system level, but typically we have a browser, it's an application. So DNS and some other services, we will see many more, typically should be in the operating system, typically, or if we talk microkernel, then it should be at least a trusted service somewhere, microservice. But now we push central functionalities into applications. Okay, and applications, depending on the setting, are at least a bit more under the control of users. So there are at least some challenges for administration of the device. So the application now decides on the DNS resolution, decides upon the server. So if something goes wrong, it's way more complicated now for troubleshooting. So what server did you access? So what was the answer? So why do you get this and that answer? I get a completely different answer. Yeah, you have a different browser, different setting, etc., etc., etc. Think of a large company with different settings. You don't want to have this. So there are means of having kind of a similar setting for all the devices, so mobile device management, all these things. But you see, and that's the basic idea I want to talk about, is we push a basic function now from the lower layers, from system services up into application. Out of control now from the classical DNS. So yes, there are big advantages. So one big advantage is that we hide DNS. So we encrypt it. No one can see it. And just by looking at DNS, you learn quite a lot. And so this clearly can be an advantage. So we don't see this anymore, and we use HTTPS, so it's encrypted. Yes, there's also DNS over TLS, TCP, so a secured version, but this also does it. There are some disadvantages. So there were some systems, for example, for parental control, that did some DNS filtering. So checking, what is the domain you're asking for? No, this is nothing for the kids. So, okay. And then with the help of this DNS or HTTP, you could circumvent this classical simple filtering. So, and there's something else. DNS, you saw the system of our root servers replicated more than 7,700, 1,760, something like this, replicated servers, quite a lot, under control of many organizations. So if one organization goes bankrupt or does something bizarre, there are many others to take over. But here, current implementations using DNS or HTTP, well, they are hosted by very few big DNS or HTTP providers. Well, for example, Mozilla used Cloudflare DNS, and there were already problems in the UK. So in the UK, Mozilla doesn't use it anymore because there were many complaints, parental control, etc. Chrome, Google, you can imagine what happens there. So there are some disadvantages coming with this idea. Oh, why should we use this decentralized DNS? Let's use DNS over HTTP. So what are some more next steps? So, okay, instead of having a few big DoH providers, why not decentralize this? So basically, in the end, any web server could deliver this. So why not? So any web server could deliver DNS information, and in addition to HTTP content, you could cache, you could distribute the information. Again, question of do you trust them, etc. There are ideas of oblivious DoH. So what does it mean? So you encrypt your DNS request, you route it via a proxy. What was the idea of the proxy? So we have the client. The client encrypts the request. Okay, that means no one can read the request but the real server, the DoH server. Then we have the proxy. So the proxy doesn't know anything about the content, but now acting as a server, at least taking over the request, and then acting as a client to forward the encrypted request then to the server. Okay, fine. The server here knows how to handle the request because you have the key, maybe public key infrastructure, you have the keys. And the proxy doesn't see the content. The server sees the content, but does not see the client. The server only sees, oh, there's a request coming from a proxy. You could think of several proxies, whatever. So the proxy multiplexes many requests, and now the server can send back an encrypted response. Then the proxy sees, okay, the response comes back, doesn't know the answer, and will then forward the encrypted response to our client. So the proxy doesn't know the content of the request, and the resolver, our server, doesn't know the client, only the proxy. So this hides the client, no one knows who the client is, and this hides also the content. So this is one of the ideas how you can protect clients. Well, if someone sits in between and tries to look into your requests. But at the same time, the server cannot collect anything about you. So there are many ideas now. As soon as you open this up, as soon as you say, okay, we go away from this classical structure of DNS and DNS servers and open this up, use HTTP, well, you can do many more things, for good or bad. So some final questions. So what is the idea? Why do we use now HTTP for everything? Remember our second small waste in our kind of hourglass model. And now we use DNS over HTTP. What is the advantage? Is this a good idea or is this a stupid idea? There's also, I mean, if we want to handle security because it's HTTPS, so it's a secure version, there's also DNS over TLS. So why do we do it? So what else besides security? And then at a kind of a meta level, we have to discuss what are more general problems when combining different worlds. The classical world of DNS where we say, okay, this is DNS, and the job of this world of distributed servers is DNS. And now suddenly we say, okay, there's another word, HTTP. The job was delivering content of web pages. Okay, and now we use this, misuse, abuse, or it's a good idea. We use this now for also carrying other content because, as we learned, DNS, it's a database, has content, request response. HTTP, also request response. And database, now it's a web server. Plus we mix layers, we mix principles. What could be problems? Why do we do this? What are the advantages? What are disadvantages?